Lesson 2.2, simplifying radicals with x, meaning simplifying radicals that have variables in them. I want to write down a problem real quick, and I'm going to put the square root of 10 squared. And my question is, what would that equal? Well, you might say 10 squared is 100. If I square root 100, that means what number times itself makes 100? That would be 10. So do you see how my answer was actually just this number? What if I do another one? The square root of 6 squared. Sorry, that looks like a Z. 6 squared. Well, then you might say, okay, 6 squared is 36. Square root of 36 is just 6. Well, it ended up with just this number. So what can we say happens? Well, a square root and a squared are actually called inverse operations. They cancel each other out. Square root and squared cancel each other out. Kind of cool, right? So if I didn't have a number, but I have x being squared, what do you think this would simplify down to? We just said that a square root and a squared cancel, so I'd be left with just x. It takes a pair of 2, to kind of split and become 1. Okay? So if we know that, let's look here at number 1. I am trying to simplify a radical. I have square root of 9x. Well, I can do the square root of 9. Here, we'll split this. I can split this apart and just keep them both under square root. Square root of 9 is just regular old 3. Well, I don't have an x squared. I don't have enough to take a pair out, so he has to stay under the radical. So my answer would be 3 square roots of x. Okay, on number 2, x to the 6th power. I want you to think about what that would look like. X times itself 6 times, all under a square root. Well, we said every x squared will just become x. So let's group them. We got x squared times another x squared times another x squared, all under a square root. Well, this is going to cancel each other and just be x. This is going to cancel each other and just be x. This is going to cancel just x. Well, what would that be? X to the 3rd power, right? There's 3 x's getting multiplied together. I don't expect you to write this out every time. The shortcut is you take the power divided by the index of the radical, which is 2. So 6 divided by 2 is 3. Pretty cool, right? If it's an even number, it's all fine and dandy. But if it's an odd, it's not quite as fun. So what I start doing is, as I get bigger powers, I will split this into 2 radicals. The first one is everything that's a perfect square. The second one is going to be things that are my leftover that have to stay under the radical. 81 is a perfect square, so I'm going to put it here. X to the 7th is odd. And remember, I'm trying to take 7 divided by 2, which isn't going to come out nice. So what I want to do is I want to go down to the next even number, or, kind of slide down to x to the 6th. Well, then I would need times another x to make 7 of them. Okay, so this should be able to all come out from under the radical. Square root of 81 is 9. This would be 6 divided by 2, so it'd be x cubed, right? I could take 3 pairs out of 6, and then I would have square root of x left over. So any odd x's stay under the radical. All right, let's try number 4. If I have something in front of the radical already, that's just getting multiplied by whatever else I pull out of the radical. Things that are touching are always multiplication. So in this problem, this is even, which is good. So that means I can just take 10 divided by this index of 2, which would be x to the 5th. And what do I do to put these together? I add 5 and 2, and that would be x to the 7th. Okay, and then number 15, I have square root of 17. I know that 17 is a prime number, so it's going to go in my leftover radical. X to the 5th, I can round down or slide down to x to the 4th, but then I'm going to have a leftover x, right? 4 plus 1 would make 5 of them. So this should get simplified. How many pairs can I take out of 4? Or 4 divided by 2 is 2, so I get an x squared out of that, times the square root of 17x would be your answer. Okay, I'm going to let you pause and try number 6. Okay, 3 is a prime number, so that goes in my leftover radical. X to the 7th, I'm going to actually go down to x to the 6th, and have that leftover x be here. 6 divided by 2 would be x cubed can come out. Don't forget to multiply by the x cubed that was already here. And we would add 3 plus 3 and get 6, and we have leftover square roots of 3x.